In this video, we are going to solve one sum based on DFT sequence, that is, compute the DFT of the sequence x of n is equal to minus 1 raised to n, where n is equal to 3. The range of n is always n is equal to 0 to n minus 1, so it becomes 0 to 2. For n is equal to 0, x of 0 is equal to minus 1 raised to 0, that is 1. For n is equal to 1, x of 1 is equal to minus 1 raised to 1, that is minus 1. And for n is equal to 2, x of 2 is equal to minus 1 square, that is 1. So we finally get the sequence as x of n, 1, minus 1 and 1. So we'll apply the definition of DFT. So we get the formula as x of k is equal to summation n is equal to 0 to 2 x of n e raised to minus j 2 pi kn by 3. Okay, so now for k is equal to 0, we get as x of 0 is equal to summation n is equal to 0 to 2, that is x of n e raised to minus j 2 pi k n by 3. So now as this value, that is k, is equal to 0, so this whole term will become 0. So it turns out to be e raised to 0, that is 1. So we are remained with x of n only. So now while expanding only this term, we get x of 0 plus x of 1 plus x of 2, that is 1 minus 1 plus 1. The final answer is 0, that is of x of 0. For k is equal to 1, we have x of 1, that is summation n is equal to 0 to 2 x of n e raised to minus j 2 pi n by 3. Now we are going to expand this term. So it comes out to be x of 0 e raised to 0 for n is equal to 0 plus x of 1 e raised to minus j 2 pi by 3 plus x of 2 e raised to minus j 4 pi by 3. So now we have to expand these exponential terms. By using the e raised to j theta formula, the value comes out to be x of 1 is equal to 1 minus 0.5 minus j 0.866 plus minus 0.5 plus j 0.866. So now finally these both the terms are cancelled. So answer comes out to be 1. For k is equal to 2, x of 2 is equal to summation n is equal to 0 to 2 x of n e raised to minus j 4 pi n by 3, that is x of 0 e raised to 0 plus x of 1 e raised to minus j 4 pi by 3 plus x of 2 e raised to minus j 8 pi by 3, that is for n is equal to 2. Now again, calculating the values of exponential terms, we finally get 1 minus 0.5 plus j 0.866 plus minus 0.5 minus j 0.866. So again, these both cancel out and finally the term comes out to be 1. Therefore, the DFT of this sequence is 1, 1, 1. We continue with the sums of the DFT. The next sum is find out the DFT of the sequence, that is x of n, given as 1, 1, 2, 2, 3, 3, where capital N is 6. So n is equal to 0 to n minus 1. So it comes out to be 0 to 5. Now we know that x of 0 is 1, x of 1 is 1, and similarly it goes on. Now according to the definition of DFT, we will find out x of k. So the general formula comes out to be x of k is equal to summation n is equal to 0 to 5 x of n e raised to minus j 2 pi kn by 6. 6 as in capital N is equal to 6, where k ranges from 0 to 5. Now as 2 and 6 get cancelled, it becomes pi kn by 3. Now we'll find out for the values of k. When k is equal to 0, x of 0 is equal to summation n is equal to 0 to 5 x of n e raised to 0. So it comes out to be the sum of these terms. So x of 0 plus x of 1 plus x of 2 plus x of 3 plus x of 4 and x of 5. So the total sum comes out to be 12. For k is equal to 1, x of 1 is equal to summation n is equal to 0 to phi x of n e raised to minus j pi n by 3. Now x of 0 e raised to 0 for n is equal to 0 plus x of 1 e raised to minus j pi by 3 plus x of 2 e raised to minus j 2 pi by 3 plus x of 3 e raised to minus j pi plus x of 4 e raised to minus j 4 pi by 3, and last x of phi e raised to minus j phi pi by 3. Now we are going to find out the values of these exponential terms. So substituting the values, we finally get equal to 1 plus bracket 0.5 minus j 0.866 plus 2 minus 0.5 minus j 0.866 plus 2 minus 1 minus j into 0 plus 3 into minus 0.5 plus j 0.866 plus 3 into 0.5 plus j 0.866. Now the final value comes out to be x of 1 is equal to minus 1.5 plus j 2.598. For k is equal to 2, x of 2 is equal to summation n is equal to 0 to phi x of n e raised to minus j 2 pi n by 3. We will expand this. So it comes out to be x of 0 e raised to 0 plus x of 1 e raised to minus j 2 pi by 3 plus x of 2 e raised to minus j 4 pi by 3 plus x of 3 e raised to minus j 6 pi by 3 plus x of 4 e raised to minus j 8 pi by 3 plus x of phi e raised to minus j 10 pi by 3. These terms may seem very long, but once they are simplified, they come and resolve to the smaller term. So we finally get 1 plus minus 0.5 minus j 0.866 plus 2 into minus 0.5 plus j 0.866 plus 2 plus 3 into minus 0.5 minus j 0.866 and again plus 3 into minus 0.5 plus j 866. Finally again we get the value as minus 1.5 plus j 0.866. We will find out for k is equal to 3. X of 3 is equal to summation n is equal to 0 to phi x of n e raised to minus j pi n. Now this would be simple as it turns out to be e raised to minus j pi n. So when we expand this, x of 0 plus x of 1 e raised to minus j pi plus x of 2 e raised to minus j 2 pi plus x of 3 e raised to minus j 3 pi plus x of 4 e raised to minus j 4 pi and finally x of phi e raised to minus j 5 pi. The value comes out to be 1 plus 1 into 1 minus 1 plus 2 again plus 2 into minus 1 plus 3 and plus 3 into minus 1. So final answer turns out to be 0. For k is equal to 4, x of 4 is equal to summation n is equal to 0 to phi x of n e raised to minus j 4 pi n by 3. Again we will expand this term equal to x of 0 e raised to 0 plus x of 1 e raised to minus j 4 pi by 3 plus x of 2 e raised to minus j 8 pi by 3 plus x of 3 e raised to minus j 12 pi by 3 plus x of 4 e raised to minus j 16 pi by 3 plus x of 5 e raised to minus j 20 pi by 3. We solve these terms, so it comes out to be 1 minus 0.5 plus j 0.866 plus 2 into minus 0.5 minus j 0.866 plus 2 plus 3 into minus 0.5 plus j into 0.866 plus 3 into minus 0.5 minus j 0.866. So it comes out to be minus 1.5 minus j 0.866. And finally the last value, that is the k is equal to phi x of phi is equal to summation n is equal to 0 to phi x of n e raised to minus j phi pi n by 3 is equal to x of 0 e raised to 0 plus x of 1 e raised to minus j 5 pi by 3 plus x of 2 e raised to minus j 10 pi by 3 plus x of 3 e raised to minus j 15 pi by 3 plus x of 4 e raised to minus j 20 pi by 3, and finally x of 5 e raised to minus j 25 pi by 3. It is equal to 1 plus 0.5 plus j 0.866 plus 2 minus 0.5 plus j 0.866 plus 2 into minus 1 plus 3 into minus 0.5 minus j 0.866, and finally plus 3 into 0.5 minus j 0.866. So the value is minus 1.5 minus j 2.598. Finally, the DFT is x of k is equal to 12 minus 1.5 j 2.598 minus 1.5 j plus j 0.866 comma 0 comma minus 1.5 minus j 0.866 comma minus 1.5 minus j 2.598. As we can see, these both and the other two are complex conjugate pairs. So it can be a way of method to check the answer. The magnitude is given by mod of x of k, that is the real part square plus imaginary part square. And for the phase, that is the angle of x of k, it is given as tan inverse of imaginary part upon real part. So we'll solve accordingly for the values of k. We'll make a table that is k ranges from 0 to 5. For the value of k equal to 0, the magnitude is 12, angle is 0. Similarly, we write other values. Now we'll plot the magnitude and the phase spectrum respectively. Looking at the magnitude values, we'll plot the magnitude graph. So for the value of k equal to 0, the magnitude is 12. For k is equal to 1, the magnitude is 3. For k is equal to 2, the magnitude turns out to be 1.73. For k is equal to 3, it is 0. For k is equal to 4, the magnitude is 1.732. For k is equal to 5, the magnitude is 3. Again, for phase spectrum, for k is equal to 0, the angle is 0. For k is equal to 1, the angle is minus 60 degree. The angle is minus 60 degree. For k is equal to 2, the angle is minus 30 degree. For k is equal to 3, the angle is 0. For k is equal to 4, again the angle turns out plus 30 degree. And for k is equal to 5, the angle is 60 degree on positive side. So we plot the magnitude and the phase spectrum. Thank you.